Good morning. The second part of 8-5 is going to be your lesson and your assignment for today and tomorrow. So if you'd want to, before you want to watch any more of this video, you might want to look at page 495 on lesson 8-5. And we're going to be looking at how to solve problems when you have to factor by grouping. So it involves example 2 and 3 on page 495. So if you want to stop and look over those for a minute and then come back to the video, go for it. So in this lesson, like I said, in order to factor all of these, it's going to be different than last week's example 1 part of this lesson. It says here that to factor by grouping, you have to put the terms into groups and then factor. So this only works if you have 4 or more terms. Okay, all of them that you're going to see today and tomorrow are going to be 4 terms. So you're just going to group the terms into groups of 2. So 2 groups of 2. So factor by grouping. So I will just look at these 2 examples on paper with you for how to work through this example. So again, if you just want to look at that example, then come and look at my videos. That would be good. All right, so like I said, here's this polynomial has 4 terms. So you have to decide how to group these where you'll be able, where the groups have a common factor. So if you look at these 2, if you look at this, you'll see that, these first 2 terms, they both share an n. So you could factor out, you could pull out an n. But then you would say, well, then these don't have anything in common, right, to factor out, so that's not going to work. So you kind of just have to kind of guess and check and see if it's going to work or not. But then here's another look at this option. The first term and the third term, they both share an r, so you could factor out r. And then that would work also because if you look at these other 2 terms, they both share a common factor of 5, so you could factor out the 5. So as long as you can find 2 pairs of terms where you can factor something out, that's going to work. So this is how I would like you to write it and show it, just so you can keep track of it and I can see what you decided to group, okay? So like I said, I put these 2 together so I could factor out the r, and I put these 2 together so I could factor out the 5. So always be aware of the signs right in front of the numbers, because that's going to be a big deal in this lesson today too. So this was -5, so make sure you're putting -5 there, for example. All right, so we would have, if you factor out the r, remember for when you factor out the r out of this, you have to put something, so it would be -1, because then think about going and distributing that r back out. You would have r times n, and then you'd have r times -1, so see how you'd end up with -r still. So you do need that -1 there. And then the same thing happens over here too. Factor out the 5. All right, so after you do that, then what you will see, and what the book explains too, is that the r and the 5, they both share a common factor of n-1. So see how you ended up with n-1 on both of these? So what you can do because of that is you can what you end up doing is you can go combine the two factors that you pulled out, the r and the 5, the +5. That becomes a binomial that you can put here. So r plus 5, I got that from this and this. And then that common factor was n-1. So this ends up being your answer, because the r was multiplied by n-1 and the 5 was multiplied by n-1. So that is what that's showing here. And just like last week, you can always, and I highly, highly recommend you go and actually go, so you could go FOIL, right? And distribute all this back out, and you should get the original problem every time. So you can always check these to make sure that they're correct. All right. So let's look at another one of those because I know these are very different. So check out B here and look and see. So, you know, right away you might notice the n's, right? So the first term and the third term both share an n, so you could factor out an n. And then here, these two both share, you could just factor out a 5. Okay, or you might see here that these both share p. And then look, these both share, you could factor out a 4. So sometimes you'll see that there are a couple options and it will all work out in the end as long as you are finding two pairs that you can pull out a common factor. It should all work out fine in the end. So I found that I decided I was gonna pull the n out of these two, so I grouped them together. And then I was gonna take the 5 out of these two, factor out the 5. All right, so I'd end up with this. Make sure that makes sense to you. So think about what we did last time. I factored out an n and I factored out a positive 5. So that becomes that becomes a binomial as part of your answer. Then look, they both share 3p minus 4, 3p minus 4. So that's the greatest common factor that we factored out of n and 5. So putting that all together, we could have n plus 5 as one of the binomials, and then the one that they shared was 3p minus 4. Okay, and for this one, let's just go prove it. Let's go, because this is what I want to see you do. You know, we can go FOIL to check. Okay, so first we'd have n times 3p. Outers, we'd add n times negative 4, so that's minus 4n. Inners, we'd have 5 times 3p, that'd be a positive 15p. And then the lasts would be 5 times negative 4, that'd be negative 20. So it's not in the exact order as above, but yes, it's the exact same polynomial, right? So we know that it is a good answer right here. So circle this answer. This is what you're looking for when you're factoring. All right, and then the other one I wanted to show you, there's one more example. Example 3 in your book. Again, if you want to look at this one before I show you 3A on paper, go ahead, because it's a little bit different. So check out this one here. So again, start looking for start looking for pairs that you can group together. Okay, so I noticed that I could pull a C out of these two, factor out a C. And on this one, I could factor out a 4. So here is where it's different and where you need to pay very close attention to detail. Okay, so if you look quickly, you might think that these two binomials here are the same, but they are not, right? So see how this first one, the one's positive, but over here, the one's negative. Over here, this 2D is negative, but over here, it's positive. So these are not the same like they were in the first two examples I showed you. So I want to talk to you about that because there is a little bit of work you have to do before you can just finish up your answer. So down here, check this out. I want you to realize that these are the same thing. Okay, look and see if you can tell what I did. So in order for this negative 2D to become a positive 2D, and for this 1 to become a negative 1, so they switch signs, right? Both of them switch signs. You would have to multiply, right? You'd have to multiply by a negative 1 to make that happen, right? If you multiply by a negative 1, all it does is change the signs. So it's just like you making whatever's out here, it's opposite. So if it's a positive C, now it's a negative C, and that's just like you multiplying by a negative 1. Okay, and I'll prove it here by actually distributing. So if I distributed out the C, I'd have 1C, which is just C. And then here I'd have a minus 2CD. And look down here, if I distributed out a negative C, right, this whole term would become a negative 2CD. And then a negative C times a negative 1 would become a positive 1C. So see how they ended up being the same answers? The 2CD is negative and the 1C is positive. So what we just figured out then is that we can go and do this. If we go and make the C its opposite, we're allowed then to go make these their opposites. And then we have a problem that looks like the first two that we did. So see how they both have 2D minus 1 now? That's what you need to make sure you have before you keep working on. So then if we just do what we've been doing, you can write it like this. Okay? Because they both have that common factor of 2D minus 1. And you're just, again, taking the two things that you factored out and putting them into a binomial too. So when you're checking answers in the back for some of them, you will see that there are two choices sometimes for answers. So this, what I chose to do here, that was just one way you could have done it. You know, think you could have done that same thing to this part over here, right? And couldn't you made this a negative 4 and then turned this into a positive 1 and a negative 2D? Okay, I hope that makes sense. No matter what, when you're working with these and messing around and trying to figure out what works and what doesn't work, you can always check by actually foiling out, distributing out like we've done in the past to see if you can get the original problem. Okay. Hope that helps. Let me know if there's one that I can do and I can make another video of it. But I'll put this on Google Classroom now. Your homework's page 498. Numbers 21 through 28 all. Make sure you're checking answers in the back for the ones you can. And I need to see this work for you to get credit, okay? Answers alone, just writing these down. I'm going to return it to you and ask you to go work them out, okay? Good luck.